Welcome everybody to our next video on Windows shellcoding. We'll do a couple great fun activities. Firstly, we will reverse engineer some shellcode, some challenging shellcode, discovering its functionality. This shellcode will make use of some anti-analysis techniques, so we'll figure out what it's doing and how it's doing it, and how it is able to potentially evade detection. Secondly, you'll get the opportunity to create your own shellcode, and I think this will be a tremendously rewarding experience. Now, as we create our own shellcode, we're not going to be reliant upon hard-coded memory addresses for APIs. That's a very antiquated technique that is no longer relevant in a modern environment where we have ASLR being prevalent. So instead, we will dynamically resolve the addresses of APIs, and we'll come up with some shellcode that can actually do something pretty awesome. I'm truly excited to see the shellcode that you come up with. Generally speaking, when it comes to exploitation, it's great to be able to use tools such as MSF Venom to create shellcode. But if you're doing that, then what you're doing is you're actually using somebody else's shellcode. As exploit developers, we need to be able to create our own shellcode from scratch, to understand the process, to be able to complete the process. And the great thing about doing it yourself is, if you do it this way, then there is no limit in terms of what you can do, the functionality that you can embed in your shellcode. So we'll have an exercise to get our hands dirty with that, and I think you'll enjoy it quite a bit. So I've gone and created a new slideshow to help us better understand some more advanced Windows shellcoding issues that may potentially come into play as we create our own shellcode. So we'll go through this presentation. It's not very long. We'll go through it fairly quickly, and then we'll introduce the lab assignment, and that will be it for this week. Now, this slide here gets us thinking very broadly about some of the more unique challenges that we face with Windows shellcoding, as opposed to, say, we went back in time 15 or 20 years and we were in Windows XP and we could just magically have hard-coded addresses for functions, or if we worked in a Linux environment. There are a number of challenges that we must face and overcome when we're working in a modern Windows environment. First and foremost, we've talked about this extensively, is we need to be able to discover the addresses of loaded modules. So things like, kernel 32, ntdll, urlmon, any and all of them. It's an absolute must that we get the address, the base address of these loaded modules. That's our starting point. If we don't have that, then we cannot progress forward. We cannot get the addresses of APIs. If we can't get the addresses of APIs, then we can't use them. If we can't use the addresses of APIs, then we really can't do anything with shellcoding. So both of these are extremely important. Now, the technique that we've made use of course, is walking the PEB, walking the PE file format. And that's the most prevalent technique. I read that it originally, I've read a number of things, so I'm not really sure about the veracity of it, so perhaps I should not comment. Some of my reading has also indicated that there may have been a technique in order to make use of structured exception handlers to discover this. I'm not sure if I've seen that in a modern exploit, so my sense is it's probably dated. There is a guy named Scape, S-K-A-P-E, who wrote a white paper on Windows shellcoding about 15, 18 years ago. And it was very informative and very influential at the time. It's probably like 70 or 80 pages. And he describes that technique And he also describes the peb walking technique as well, although some things are a little bit different in there. For instance, the instruction where we add C to get to our LDR, he does 1C. So times have changed, and if you go back and look at his work, some of it is a little bit dated. And I would encourage people to check that out, but just also understand that some things have changed, and if you're not really sure what has changed, then I'd read it with a grain of salt. That's always a danger of reading anything old that deals with security or techniques to overcome security, because a lot of things may change. In this course, we deal with techniques to do modern exploits. I think going and using return-oriented programming is fairly modern. There are some additional mitigations that we could also introduce that can make things more challenging, but it's a game of cat and mouse. They present one obstacle, you overcome that. If you're able to do some complicated ROP or non-trivial ROP on your own, then you're in a really good position. And if there are additional mitigations that arise and you need to overcome them, then it makes it a little bit easier to do that. Certainly there can be some environments such as Emmet, where Emmet is used, that can create quite a bit of problems. And in that case, the techniques would need to be a little bit more specialized, but I think we are digressing a little bit there. So again, we need to discover addresses of APIs once the modules have been loaded. An additional problem is, what if we want to call on an API, but the module has, or the library, the DLL has not been loaded? How can we do that? Well, we've seen how we can do that. The load library A, we can make use of that function. So these are all important problems that don't have an easy solution, but through the last few videos, I think we've come up with some ways that we can address these problems. I want to talk a little bit about decoders. So as a reminder, decoders is a mechanism that can allow us to add some additional stealth, some additional security. What that means is, what happens if you have some ASCII in there? Maybe you're doing a load library on a particular function, or you're downloading something from a particular address, and that's not hashed, it's not encrypted. Well, you can't really hash something like that, so but I mean, it's not encrypted, it's just in plain text. So that could be potentially dangerous. If you add a little bit of additional security by encrypting it, that just makes it all a little bit harder for the wrong person to be able to read it and to understand it. But that's not really our main reason for doing that. The main reason that we make use of encryption techniques with shellcode is simply to avoid bad bytes, null bytes, or others that may exist. Thus, we can view a decoder as simply just being a function of sorts. We can expand our X into a different character space. Now, we can also be confronted with the issue where if we have a very strict, very stringent filter for many, many bad characters, what do we do? How can we address that? That does become quite a bit more challenging. I'm not sure the best approach for that, except to say, we could try to approach it one step at a time. Meaning, if we can figure out a way to exclude a certain bad byte, then we could do that and potentially have a series of different decodes, each of them addressing different aspects of the filter. Of course, that's a little bit easier said than done. and it still leaves out quite a bit of implementation details. And so an approach like this can invite quite a lot of creativity. There's also the challenge of how can we do this but not consume a huge amount of space, because size is always a consideration with shellcoding. So as you are developing this, this is my idea right here, of course. My idea is you could have an array, a list of different bad bytes that you wish to avoid. You could enumerate, you could cycle through them and see if the resulting shellcode, however you create it, whatever series of decodes you utilize, if in there these bad characters are present. If they are present, then scratch it, maybe try a different key value, and do the whole thing again. So what do I mean by that? I mean that maybe you're doing exclusive OR at a certain location, and you have a key value of, say, 23. 23 doesn't work, so you try 24. That could be one approach, and you could just cycle through things and just let it go until the resulting shellcode is free of the bad bytes. In terms of actual how well that would work, that's something I'm not prepared to speak on, but certainly it's worth a try. And obviously a CPU can perform these operations and cycle through a vast number of potential candidates for a key very, very quickly. So it may not be as bad as it sounds. Downloading. So there could potentially be considerations when downloading. What happens if you're trying to download a file and it takes a longer period of time? You want to make sure that there's sufficient time before you do your next operation. Say you're using a sequence of Windows APIs. Maybe you could use the sleep as a means to make sure that there's enough time for the download to complete. That could be one potential approach. Obviously, there could be other approaches as well. This says alignment issues, but I also talk about something else as well. Now, when you do this, there can be some very strange alignment issues, because sometimes Windows behaves in a dumb fashion, in the sense that ESP, for certain instructions, needs to point to an address that is a multiple of 16 bytes. So there can be certain SIMD instructions performing parallel operations on multiple words in memory, and it requires that this be present, that ESP be aligned correctly. If it's not, then you'll have an error, and it simply will not work. So the way that we can do that is this simple instruction right there can fix our alignment issue. In particular for WS232, which I think stands for WinSock 232. Don't quote me on that. But that in particular sometimes does need ESP to be aligned correctly for certain functions. I mean, you can certainly try it without that, but if you're running into issues, then this could be one potential cause. So, better safe than sorry. And of course, if you're testing things in a debugger, like in a WinDebug, and you can just do it step by step, and you can always see if there are issues that may come up. There can also be some weird issues right here. I've seen a shellcode where this has not been done. So, and the source where I found this in was a little bit older. So, I'm not sure if this is necessarily relevant in a Windows 7 or Windows 10 environment. However, if there are issues and things aren't working quite well, then maybe better safe than sorry to try it. But if you can get it loaded without it, then great. no need to do it. Some of the, I think one of the examples I showed you guys yesterday, we had it, and it was done successfully without this. But shellcode in a Windows environment can sometimes be very tricky. But as it says right here, sometimes WS232 will not load unless this function from this DLL has been called first. And the reason why is because as you do this, as you're trying to load WS32, you're doing it as an anonymous user, and an anonymous user may not have the necessary permissions to read files. So it can be a permissions issue. The solution is just simply to call this function. Now this API is often present in binaries. If you're not sure, you can open it up inside WinDebug and check and see if it's there. If it's not there, then you'll need to load it, so use your load library. But if it's already there, then, and it often is, then there's no need to load it. Now, using what I provided with you, the skeleton, you'll want to make sure you have a separate hash table and function table for each and every the DLL. So this would be a separate pair of them. Some more information on using WS232DLL. I would invite you guys to make use of WinSock functionality to be able to download things or upload things. I think that adds some sophistication to what you do. Of course, it's up to you in terms of deciding what it is you want to do with your shellcode, so you don't have to. But you definitely want to carefully investigate some of these to see, and this part of this is an exercise where you'll need to do research. As part of this class, I explain and teach you guys a lot, but I do intentionally leave some things open-ended to invite research. Probably should do more of that, but in this case, this is one where I do want you to dig a little bit deeper. But at bare minimum, for a lot of these functions, you need to call this particular API. If you don't call it, then it's not going to work. So that's often going to be a case here. As to parameters you need to use, other associated functions from the WS232 that you may be utilizing, part of that is what you need to do. Of course, and let me get my pen here as I struggle to find what it is here. I'm using my finger here. You can use MSDN as a great resource to find information on, it's supposed to be an arrow. Use MSDN to find information on all of those functions, the parameters. It'll give you everything you need to know. You can also find other examples either from MSDN or elsewhere. If you are struggling and you're running into problems, you can also use the WSA get last error. If it is 0 is your output, that means you did a good job and it worked. But if you get other error messages, other error codes, then you'll have to look them up, and that will tell you, give you insights into what's going wrong. What are your problems with the WinSock functionality? So some of them are descriptive, and so you may be able to figure out what it is. And I never know how to escape this. Oh, that's simple. So yeah, definitely check that out if you're struggling. I don't mean to scare people away from using these. I've seen people use these and WS2 functions and be successful. And if you want to do that kind of thing, downloading or uploading, then it's an obstacle that you need to face. So might as well confront it and get it over with. Some more troubles. Sometimes the library may not find WS232 unless the entire path is specified. This is another thing where I think it may potentially be just something that's old. from the source that I got. But if you're struggling and then you're having issues, then you can try that. So you try to get system directory A to get the path, use a buffer, concatenate it. So you could prepend the path with the WS32 DLL. And if you need to use this, you can go to the Shellcoder's handbook, which is one of your assigned readings. Actually, I guess it's recommended readings, but it's one of the books that you purchased, and that gives a description on some of that process. I don't think it'll come into play, but if it does, then you could try that. Well, I guess I had wrote that down there, so I guess my enthusiasm for making obscene drawings got the best of me. Get process address. This is something else that you could make use of. We talked about this a number of times, so we can use the library to load a library and get proc address. We can get an address for a particular function, a particular process, or a procedure, which I guess is another synonym for function. So say virtual protect, you want to get the address for that, then you could call that. If you were writing something in C code, C++, you probably would use that instead of making use of walking the peb and the whole elaborate technique that we utilized. Now, in your actual shellcode that you're creating, as long as you get kernel 32 loaded and load any other libraries that you want, if you want to use get proc address as a different way of doing things to get the address, I'm fine with that. That would be a departure from the skeleton and the techniques that we discussed in our last video. At bare minimum, you need to use that skeleton. You need to use it to get at least the address of kernel 32. But if you do that and then you decide, hey, I'm going to make use of get proc address and take a departure, then you could do that. Another issue, though, is I also require that for the APIs that you use the hashes. So I'm not sure how you would use the hashes with this. I guess you could. I mean, the decoding aspect of it is in there. You would just need to rewrite some of the shellcode to decode the hash, and then use the hash with get proc address. So for your assignment, I think using this would maybe be more trouble than what it's worth, because the skeleton already provides a way to do it. It's already modular. They're just different functions inside of the shellcode, and you can use them or because they're already there. But if you do decide to do shellcode on your own and you're doing something outside of class and you don't feel like using that, and you don't have the restriction of needing to have your functions be hashed, then maybe you might choose to use get proc address. Certainly, it is common to see people use the technique that we used and also use get proc address. So you get started with the technique that we saw in our last videos, and then you might move on to get proc address. So there is a little bit of freedom there. So this is kind of a clever title. Getting a shell on Windows is dumb, and it really is, because if you think about it, it may seem like a good idea to get a shell, meaning essentially you have access to the command prompt. You can type commands into the command prompt, and if you can do that, then you have a tremendous amount of freedom to do a lot of dangerous or powerful things on somebody's system. But it's really not as good as it seems, because you actually can do just as much, not only just as much, but more using the Windows 32 APIs. It's just using it in a different way, a way that you may not be used to, because we don't traditionally, a lot of us don't really use Windows APIs, but we can. Transferring files is one thing. If you decide I'm going to get a shell, then your ability to transfer files back and forth becomes much more difficult. I mean, you can do it. It just, there's a lot more work involved to do so, rather than using, if you just stayed with Windows APIs. You also, when you're in the shellcode and it starts out, then you have the current threads token. But if you then go to the command, you get the shell, then you're replacing it with the primary token of the process. Sometimes that may be to your benefit. Sometimes it may have no effect, but other times the primary token could be lower privileged. Does that always come into play? No, but potentially it can. And problems with tokens can be some of the biggest obstacles when you have more elaborate, complex shellcode. So, it's always something to try to rule out if you can. Some other issues, if you make use of shellcode to transfer files and then execute it via command prompt or the equivalent of it, then your spawn process may not be able to read its own executable, as it may be a different user. So who's the user? What's the token? That all can come into play to haunt you. If you're using the Windows APIs, then it's much easier to read and write files to different users. And there's a lot that is unsaid here. Your Shellcoder's Handbook provides a little bit of information, but even that doesn't tell the full story. So when you're doing something more elaborate and complex, then that can involve some experimentation, some additional research in order for it to be successful. There can be a number of different issues. The more complex you get in terms of what it is you are trying to do. For instance, spawning a process via shellcode is not necessarily a straightforward, simple process. One thing that you would want to do to help you out with that is use create process as a user rather than simply create process. You also need to make sure that you're utilizing appropriate Windows privileges as well as primary tokens. Windows Explorer can be something that you can use to engage in analysis of different tokens that may be at play. Maybe help you figure out what it is that you may need to use, what should be used, as well as when you're actually experimenting and testing your shellcode, you can check to see, okay, what's the shellcode, or what's the token here? Is this the token that I expect or not? So Process Explorer can be useful in that sense. Of course, some of these last couple of slides get into some more advanced issues, and you're not required to do that for your assignment here. But if you were interested in doing some of those things, then certainly it's something to be aware of. Just in general, the more advanced we try to get with exploitation, the more challenging or difficult it becomes. But just because it's a little bit difficult, it doesn't mean it's impossible. We just figure out how to do it. We figure out the way around it, and we do it, and it's no longer an obstacle because the obstacle has been overcome. Now, when you go to do your assignment, you'll have some opportunity to be creative and think about what it is you want to do. And if you have an idea for something that is fairly complicated, or even if it's not complicated but you're not sure how to do it, it's an opportunity to engage in research, which is part of the process for a graduate student. And I like to have all my students, whether graduate or undergraduate, do a fair amount of research. So sometimes hacker groups, hacker forums can provide some information on utilizing APIs. People that hack video games, there can be some good examples for some of that, some basic stuff there. Some of that, though, may not also necessarily be relevant for what you may wish to do. Another approach could be simply to to find some resources on Windows APIs, write some code in C or C++, compile it, open it up in IdaPro, open it up in WinDbg, Ghidra, whatever it is you like, and see what does the disassembly look like. You could take that disassembly, you could modify it, you could see the values that are being used for parameters for something that you may want to do. For instance, maybe you know the plain text that you could provide as a parameter if you're doing it in C or C++, but you're not sure on the hex. A lot of times MSDN will give you that information, but if it doesn't, or even if you don't want to use it, you could try that trick, and if it's correct, then it'll be done in hex. So you could see the hex value, which of course is what you want to use when you're doing it in assembly. We provide the parameters as hex. Just like when we were using our virtual protect, we did RWX is hex 40. That's one example there of what I'm talking about. Okay, so I provided some files to you, and there's a couple more that's not here, but they will be there. And I'll probably take this one away. But this is the assignment that we have here. So two parts of it. The first part is we are reversing. So if you recall from our last video, I used the SC test offset. So we take our shellcode, we put our shellcode right there. You have your sample. This is the shellcode. You will use this script. This is a Perl script. It's not Python. And you will provide it with this, and you'll do it on Cygwin. It'll give you output. You'll take that output, you'll paste it inside here. You'll run it. You'll get your Visual Studio. Maybe just go like this, developer prompt, and then CL, whatever the file is called. So everything that I showed you before, nothing new. So that's the process for getting the bin file, the sample bin, loading that up with this harness program, and then we debug it in WinDbg. If you're not sure how to do that, review our video from our last video. It shows you exactly how to do it, so just copy it step by step. So first question here is figure out the technique being used to obfuscate a portion of the functionality. So figure it out and explain it briefly, so like a paragraph at most. At minimum should be a few sentences. And then the second part is there's some anti-analysis techniques going on. Respond to these questions and provide the appropriate responses. You may need to do a little bit of research. You'll need to spend a little time with WinDbg. In our last video, we covered a lot of the functionality of how it deals with the PEB, deals with the PE file format. So, I'm not concerned with those aspects. I'm concerned with the anti-analysis aspects. And you'll only figure that out by using it in your WinDbg, or if there's another debugger that you may wish to make use of. Finally, I ask what happens if it does not detect a virtualized environment. That is, what is the final payload? So figure out that possibility. And the focal point of our lab here, so we have 5 points here, we have 10 points here, and there's some bonus points as well, so you can actually get, I think it's another 4 or 5 points. So I provide you with the skeleton that we used in our last video. I provide you with the hashes script. And what I ask you to do is to utilize 3 Windows APIs to do something somewhat non-trivial. Now, what is trivial, what's non-trivial, that's up to you. If you're somebody who is and you got to be honest with yourself, of course. And I don't mean this in any kind of dismissive or derogatory sense. If you're feeling like you're really struggling, then you might do something more trivial with it. But you still need to use 3 APIs. But in that case, you might not be thinking of doing something super complex. You just may be trying to figure out how can I survive this lab. So depending on what your capabilities are will depend, and I guess I shouldn't say capabilities, but depending on your current knowledge and current skills, because we can always upgrade our capabilities. That'll help you determine the direction that you may wish to go. I do require you to use hashing. Maybe I'll boldface this. If you don't use that hashing script, then there will be problems. I mean, you really have to use the hashing script. If you're not using the hashing script, then that means you probably went and found some other script that somebody else wrote and you're just copying that. So something like that would be academic integrity violation, and there would be no points and some severe consequences, which obviously is not the case for 99% of the students, because most of the students are very hardworking and would not consider that. But we do need to make use of the hashing script. Now, if you want to create your own hashing, you can do that. So we have the create hashes script. Just as long as you encrypt something, you also have to be able to undo it, to decrypt it. So you need to figure out a way how to do that in Python, write the script, and then decrypt it in the assembly. I don't expect anyone to do that, maybe 1 or 2 people if they have more free time. But I put that out there as a possibility. So most of you will just use the hashing script that I provide, and you'll just use the skeleton. You'll make a few modifications to the script, the to-do section that is clearly marked, and provide the kernel 32 hash. And then I have some requirements here. I want a description of what you did. So spend a paragraph or 2 describing the functionality of your shellcode. Not only that, but I want the actual ASM file that you create, and it should have comments. For the parts you added, you don't need to comment the parts that are already there. I know what that does, and I don't expect you to necessarily remember all of it or understand all of it. It's great if you do, but there's a lot going on. Just as long as you make it clear what the part you are doing does, that tells me that, number one, you're providing a good script that can be reused. It's clear to somebody who gets that script what it does, and also lets me to know that you're the person who created this because you understand how it works. You'll compile it with NASM just like I did, just one command. You'll get a bin. I want the bin as well. And then you'll also use the SC tester file to incorporate the hex codes. I want that as well. So there's a lot of different things that I want, and I want that renamed as such. And you use the same technique as you would use right here. So you would use that PVE finder, is that what it's called, or PVE bin, to get the bin turned into hex opcodes. I do require that you use the skeleton that is provided. You must use hashing for modules and API names. The only exception is if you're using the library A to load something. In that case, you don't have to hash it, just because that'll create a little bit of extra work for you. So in that case, you can do it kind of like the examples we did in our video last time, and you could just have that down at the bottom as a variable, and you could make use of that, or you could just push it onto the stack. So a couple different ways in which you could do that. If you want to do your own hashing scheme, that's great. Just include the script that does the original encrypting, and also a little bit of explanation of how it works. Very important, your work must be original and it's to be done by yourself, not as part of collaboration. If you have a friend that you work with and you want to ask for help, that's okay. I don't mind that. You could share tips and techniques. But if you guys start collaborating and doing work together, then that's an academic integrity violation. I do take that very seriously. So again, it's great to work with others. Just make sure that you're not collaborating, you're doing independent work. Your friend isn't doing something for you. Sharing tips and techniques, sharing information, that's okay. Now is the opportunity here for extra credit. I thought about requiring everybody to do this, but I don't want it to make it so difficult that some of the newer people are not able to do it. Because I want people, it's tremendous. You get a tremendous sense of satisfaction and pleasure when you finish something like this. If I add this extra credit part here, that just may raise the level of difficulty a little bit too much. Now, in order to do this, here there are different sources online. I did describe in detail the steps in order to do that, and I believe in my original shellcode video, so you could go back there and see the recipe that I used for that. So here is essentially you're just creating a decoder. Now, my recommendation is to do bitwise operations. Exclusive OR is probably going to be the safest way to do it. Just keep in mind, whatever you do to it, you just need to undo it in opposite order. And once you do it in the reverse order, it should be returned to its original state. So when you do this, you would do it byte by byte. I guess if you find another way that works, I mean, you do whatever you feel like doing, but that's probably the more traditional way of doing it. So I would do, if you want to do this, I'd come up with a way to encode or encrypt something, and then test to make sure that it can be decoded successfully. You don't need to necessarily do this in assembly. You could do it however you want. You could do it mathematically. You could do exclusive OR on a calculator. Just figure out if you can undo it safely, and I'll just do it one step at a time. If it works, then maybe you write a Python script to do it. Maybe you do the encryption in assembly. It's up to you. But at the very end, you'll get a final product. The final product will be this assembly right here, which is now encrypted. So for this part, you will take that encrypted assembly. You'll have your decoder, like right here could be your decoder. Then at the bottom, you would have your encrypted shellcode. Part of the decoder would decrypt it byte by byte, just doing it in the reverse order of what you did to encrypt it. So for the decoder, you don't include the encoding process. That process has already been complete. You place the encoded, the encrypted shellcode, which would have been task 1, down here at the bottom, and then you decode it in memory in place. Just restoring 1 byte at a time to the original state. Once it has been restored, then you transfer execution to that point, and then you execute those now decrypted instructions. So in order to do that, to get credit for this, what you use here needs to be this. So you would be decrypting task 1, or encrypting and decrypting task 1. They need to match. And you just provide me with the same stuff as above. I need to see the assembly, I need to see the bin, the tester. And the reason for that is I don't grade these things by looking at screenshots and going, okay, here's a calculator, here are some points. I verify to make sure things actually work as they are represented. So that's why these need to be present. For deliverables, I have a sentence here saying you got to turn everything in, otherwise you don't get points. So if people forget to turn some of these things in, then that just means I'm not able to grade it because I can't verify, and I don't just take a description or a screenshot. That's not sufficient. Now when we grade task 1, and this only pertains to task 1, if you do task 2, great, you get your extra credit. As long as it works. If you do it and it doesn't work, I might give you like a point or something. As long as it works, you get 3 points. For the grading of the shellcode, this is the rubric that I use. Now this whole section here is worth 10 points, but if you get 3 exemplaries, then it's 12 points. So that's potentially 2 extra credit points. So I grade you on 3 different things: API usage, and this, you can read it here to see what I consider unacceptable versus meets expectations or exemplary. So if you do essentially what I asked in task 1, then you'll get 9 points. You'll get meets expectations. You won't get 12 points. You'll get 9 points. To go above that, then you need to go a little bit above and beyond. And sometimes for some of these that may be too difficult. And some of this is obviously subjective, but if you read what it's asking, what I'm asking, then some of it does ask for a lot. So, coming up with using APIs to do advanced functionality or impressive functionality relevant to exploitation, that might require quite a bit more work than just getting 3 APIs to work and do something interesting, a proof of concept. If you have limited time and you just want to complete the project and get a good grade, then you do the meet expectations. This here is just a chance for you to rise up and get some more points, to challenge yourself a little bit more. So if you do the bare minimum, I shouldn't say bare minimum, but if you do the meets expectations for what I ask up above in task 1, then you get 9 out of 10 at 90%. It's still an A, but it's not a perfect. As always, the grades I give are immutable. I don't change them unless there's a severe egregious miscalculation. I don't negotiate on a point or half a point for this or that. My decisions are final. Comments, that should be pretty easy. Creativity, so showing exceptional creativity and addressing challenging problems, doing tricky things, original thoughts or ideas. Those are things you would indicate to me in your comments and also in your write-up. So explaining some of that and why why what you're doing is so impressive. We talked about some of those challenges that are inherent in some of the WS32. So if you're addressing, or token issues, if you're addressing problems like that, and you're able to do it successfully and purposefully, then of course I'm going to give you an exemplary. But you also have to explain it so I understand that you're doing that. All right, well, that's all I have, and I hope that you enjoy this assignment.